Next topic, capacitance. Literal meaning of this word, capacity to store charge. How to express it in expression? It will be, see, the last topic which we did was about electrostatic potential, in which we deduced the expression for V, that is V was equal to KQ upon R. It also gives us the relation between charge and electric potential, that charge given to a body is directly proportional to potential on it. V was KQ by R, right? So as soon as the charge increases, so the V will be increasing. Hence, I have to equalize this equation, I will be putting a constant of proportionality. In this case, it is C. This is the equation for capacitance on any capacitor. The SI unit for now, SI unit of capacitance would be what? 1C is equal to 1Q upon 1V. In other terms, look at this formula. C is equal to Q upon V. 1 farads is equal to 1 coulomb upon 1 volt. Farad is actually a very big practical unit of capacitance, because a coulomb is a very big unit of charge. 1 farad, if you have to define it, how would you define it? 1 farad is said to be capacitance of that capacitor which stores a charge of 1 coulomb and has a potential difference applied of 1 volt. Or in other terms, you can just jumble these three words. All you have to do is you have to keep your relation between F, C and V. When 1 volt of potential difference is applied across a capacitor so that it stores a charge of 1 coulomb, then its capacitance is said to be 1 farads. How do we practically apply this formula? Consider, okay, I'll also tell you the dimension formula, how to derive the dimension formula, but first let us apply it on a spherical capacitor. Consider this is our spherical capacitor and I have given this capacitor a charge, a lot of charge, overall equivalent charge equal to Q. Its voltage would be V, the potential. So C is equal to Q upon V. What is potential for a spherical conductor having charge Q? Same formula. V would be equal to 1 upon 4 pi epsilon naught Q upon R if it has a radius R. This cancels out. This whole thing goes up. So value of C comes out to be 4 pi epsilon naught R. So this is the formula for capacitance of a capacitor, of a spherical capacitor having radius R. Now, note that you can apply this same formula for finding capacitance of Earth. If we know the radius of Earth, right? Earth is a big conductor, big spherical capacitor. It will clear you one more thing. This, consider any circuit, whatever circuit, and the next part, this end is connected to Earth. What do we mean by Earth? Having zero potential. So why Earth is called 0 volt? Why? The reason is very simple. According to that formula, V is Q upon C. Value of C for Earth using this formula is very large. Very large. C, R is 6400 kilometers. This thing becomes very large and hence this V is approximately equal to 0. Hence, the potential of Earth is always taken to be 0. Here, how do you deduce the dimension formula of any physical quantity? Let's start it right here. I have to deduce a dimension formula for capacitance or this SI unit farads. How do we do it? There is a very simple method. You know a formula. I'll tell you one formula of class 11th which is very easy for you to understand, and then we will solve it for this. I'm not doing for Q is equal to CV now. I'm using another formula from class 1 plus 1 which is F is equal to MA. I want the dimension formula of force. When writing the dimension formula, we keep all the physical quantities inside the square brackets. Then F, the dimension formula, I don't know which I want, dimensional formula of M into dimensional formula of A. M is mass. Dimensional formula of mass is M. A is acceleration. Acceleration is what is the SI unit of acceleration? meter per second square. Meter, that is length, second square, that is time. So here the dimensional formula is LT minus 2. So this whole becomes the dimensional formula of force. So the idea was, what we did here, we used simply the formula and the SI units and we converted them into the dimensional thing. The same thing which right now we are going to do for the capacitance. The formula for C here is C is Q upon V. In terms of SI units, what is Q? Now 1 ampere is 1 coulomb upon 1 second. Is it true? Current is rate of flow of charge. That means 1 ampere is 1 coulomb upon 1 second. That means 1 coulomb is 1 ampere into second. And this is the units. I'm writing these things in terms of units, and in terms of dimension formula, this thing will become A into T, right? I'm erasing this part so that you might not get confused. Alright, coming to this point again, I want to write the dimensional formula. What should I be doing? Q upon V. What is Q? A into T. What is V? What would be the dimensional formula of V? While doing potential, what was the basic definition of potential? Potential was work done per unit charge. Let me write it in red pen now. Potential was work done per unit charge, right? This was the formula. What is the formula or the SI unit of work? Work is force into distance. Force is kg meter per second square into distance into meter upon charge, ampere into time, AT. This is in terms of dimension. So kg meter square per second square upon AT. Voltage, potential, the dimensional formula of work would be kg, that is m, meter square, L square, per second square, that is T minus 2, upon A into T, which will go upwards. And hence the final dimension formula, m minus 1, A square, L minus 2, T 4. This is how we deduce the dimensional formula of capacitance.